Welcome back to Engine Shop Joe. We finally made it. We're going to wrap up features and parameters today. Remember, we've been talking about automotive features and parameters. There's an entirely different set of industrial features and parameters. I'm probably not going to go over those. I don't think there's that much of a need for that. So let's wrap this up. We're going to start up at the top. You see Smart Coast and Smart Excel. If you have a fully automated transmission like an Eaton Auto Shift, you can enable these, and what happens is when they're going down a hill, the transmission will be actually the clutch will be disengaged by the engine ECM to save fuel because you don't have the engine dragging, you're just free coasting. And then smart acceleration is another fuel saving item. They go hand in hand. Basically, smart acceleration controls how aggressively the engine throttles as you're accelerating through a particular gear. Starter lockout, that'll be enabled so that the engine won't crank at certain times. If you enable that, you might be able to, you might see that on like a bus, a commercial bus where they have a side door, and if that door is open, or if there's a back door in a school bus that's open, the starter will be locked out. It won't start till the driver, closes those doors. You can also use starter lockout that once the engine's running, the operator can't try to start it and grind the teeth off the starter. That happens in situations like a vac truck where there's a second engine on the truck and the thing's roaring and the truck's sitting there and he forgot that he left the engine running, can't hear it. They'll get in and try and crank it. So that's what starter lockout's for. Sudden deacceleration event settings. This is a tattletale on the driver to tell the company how reactive he is when it comes to slowing down or situations on the road. And there's a sudden deacceleration rate threshold. It's usually set to 7 miles per hour per second. That is how fast the truck is slowing down. So if the guy's going 70, if he slams the brakes on and he's slowing down 7 miles an hour or faster per second, it's going to log a fault code. He doesn't know it, but when they pull the faults, they'll see that fault code. And if he slams the brakes on 30 times in a trip, you'll see 30 of those fault codes. It doesn't derate or do anything else. It's just a tattletale. Switched maximum engine operating speed. You can install a switch in the cab. If the driver flips it, the engine will only ever run that fast. A lot of times they use that when they're driving a pump off the transmission and say they're spraying in a field or they're running next to a hay baler and they want to run there for X amount of time. So they'll flip that switch on and just push the throttle down, and they don't have to worry about speeding up or slowing down because it stays right with the tractor, farm tractor that's pulling the baler. You get the idea. Tire wear adjustment. I've never seen anybody use that. Maybe once on a fleet truck, like a Warner truck. It was turned on. All that does is it's fine increment adjustments to tire height to make trip mileage as accurate as possible. Okay, transmission setup. You enable that if you've got overdrives in the transmission. So you've got gear down transmission ratio and then top gear transmission ratio, and you could have overdrive transmission ratio. So these are written in the calibrations. You can't add or subtract the descriptions by the toolboxes. So if an engine had a transmission put behind it that actually had an overdrive and not gear down ratios, it would have a different ECM calibration in it that was set up for that to be matched with that transmission. So you won't see stuff in here that you shouldn't. Transmission type is manual, partially automated, fully automated, special. There's a couple more. I don't remember what all of them are, but you don't want to change that. Trip information. So what this is right here is there's two different functions you set in here. Let's go to vehicle over speed 1 and vehicle over speed 2. You see the mile per hour to the right? So when I go in and pull all the information out of the ECM, say the truck comes down for us to repairs and it's had a new driver in it for 3 months, I pull the trip information and look at it. And if I set vehicle over speed 1 to 78 miles an hour and the driver drove 80 the whole time, when I look in the trip information, there's two lines called vehicle over speed 1 and 2, and it will have time in there. So if the driver drove the truck for 40 hours and for 30 hours he drove over 78 miles an hour, it will say 30 hours in vehicle over speed 1. And vehicle over speed 2 is so you can have two settings. The other four, ECM distance offset and time offset, are only used if the ECM has failed and you replace it. So let's say the truck had 50,000 miles on it and it had 3,000 hours and the ECM failed. When I put the new ECM on, I would go in and under ECM time offset, I would put in 3,000 hours, and under engine distance offset, I would put in 50,000 miles. And then the trip information will be accurate for the total vehicle, the chassis, not just the ECM. So this is all about keeping the trip information that you print out and look at for the chassis correct. Now, the odometer on a dash is another story. The odometers are required by law to have a memory in them so that they remember how many miles are on the chassis. So if you pull an ECM out and put another one in, it doesn't go down to zero if there's 999,000 miles on it. And the legal authorities did that because not so reputable dealerships would just buy a Recon ECM and put it in a truck, and they would put 200,000 miles offset in there, and it would show 200,000 miles on the odometer. And they'd say, yeah, this has only got 200,000 miles, when in fact the engine had 999,000 on it. So you get the idea. A variable rate vehicle acceleration management is another specialty setting. That's best set by the OEM. It'll be with usually an automatic or a special kind of transmission. And it can either be to protect the device that the engine's driving, or it can be to control that particular type of vehicle in a certain situation. Remember, these engines go in all kinds of vehicles that travel over terrain and or highways. Vehicle speed sensor anti-tampering, that's enabled in all the trucks that I see, and usually it's set to high. I always set it to low in our fleet. All that's for so that the driver can't cut the wires going to the vehicle speed sensor and drive as fast as the engine RPM will let him go when he's gear bound. That's all that's about. Why do I set the sensitivity to low? Well, not so much today, but 20 years ago, if a guy was on, say the turnpike, and there was an accident 30 miles up the road, and it had filtered back, and the police are letting people through, and everybody's going 30 miles an hour. The guys would set their cruise for 30 miles an hour, and even if traffic ahead of them sped up a little, they would just leave it at 30, and that way they didn't have to step on the brake, shift through the gears. Step on the brake, shift through the gears. Well, in the old days, 20, 25 years ago, after the ECM saw that you drove for 60 minutes, and that's what I was told was the magic number back then. This is actually an N14 Select Plus. 60 minutes, the ECM would lock out to 5 miles an hour because they believed it was tampered with. And the only way to fix that is it had to get towed to where there was insight, and you had to recalibrate the ECM to drive that out. If you turn that sensitivity level to high, I think it just cuts the amount of time down that it looks at before it trips the fault. When you set it to low, it enables more time. I never saw a problem with that in the last 10 years I worked with that fleet, but it's just what I did. If I bought my own truck, I would turn that whole feature off, because if there was ever a time where there was a problem and the vehicle speed sensor failed, if you unplug it and that's turned off, you should be able to drive as fast as you need to drive down the highway. Obviously, you won't know how fast you're going. The speedometer is not going to be registering anything, but at least you can get off the road. Okay, vehicle speed source. That's enabled whenever there's a sensor, whether it's in an automatic transmission or a stick, when there's a sensor that tells the ECM how fast you're going. And by the way, it tells the ECM drive shaft revolutions. That's all it tells it, just revolutions. It has no idea how fast you're going. That is all calculated by the calibration to be driver friendly. It looks at thousands of RPM in a minute to figure out speed source. Maximum engine speed without vehicle speed source. So whatever this RPM is set at, if you unplug your VSS, that's as fast as you're going to go, because that's maximum engine speed with no vehicle speed source. If the sensor failed, that's as fast as you can go. If you get in a truck and start it up in the wintertime and the driver's like, oh man, it's cold, and he floors it because he thinks it's going to get warm faster, that's as fast as it's going to go till it sees road speed. Well, it's not going to see road speed till you put it in gear, right? So that's what that's all about. And back when I talked about PTO, and remember the PTO in this engine, the maximum PTO speed was 1400. That's because this setting controls that, except in alternate PTO, then it doesn't. Tail shaft gear teeth, that's how many cogs are on the sensor that the vehicle speed sensor, on the ring that the vehicle speed sensor is looking at. And of course, rear axle ratio, you know that. Tire size. Tire size is in revolutions per mile. It's not an actual tire diameter. You can go on Google and type convert tire size to tire revs if you need that number, and it will tell you what they are. Vehicle speed sensor type, magnetic, that just means if you take the sensor and pull it out and you put, say, a feeler gauge that was made out of steel, not stainless, on the end of it, it would stick to it. There's a magnet in it. That's all it means. It uses a magnetic field to read it. And then 2-speed rear axle, if that's enabled, the ECM knows that you have a 2-speed rear end. This particular set of parameters came out of a very heavy hauler, so it did have a 2-speed rear end. And then if you enable two-speed rear ends, you have to tell it what the axle ratio is. In this field, you're telling it the low range, which in our case is 531, and then the standard range is usually, I don't know, maybe 430 or something like that. And then you have to tell if it has a water and a fuel sensor. That's a sensor in the bottom of the fuel filter that's on the frame. They call it the primary or first fuel filter. And that sensor will be in the bottom of that filter. Congratulate yourself. This was a long, grueling series, but we're done. If you guys have questions on stuff, just post them, and I'll answer them the best I can. Okay, thanks. Thanks for joining me on Engine Shop Joe, and for being a subscriber. Have a good day.